Hey there. Okay, we've got this casino problem that we're going to work on, and casino always shows up in probability. So let's go ahead and get started working on this. We know that we're working with a deck of 52 cards, and there are four suits. It's just a typical old deck of cards, and it's been completely mixed up, and we're going to draw the first two cards without replacement. So this is important right here because this means that once we draw one card, we're not going to put it back into the deck. There's no possibility of redrawing that card. So we'll need to consider that as we're working through here. So on the first one, we're looking at the probability that both cards are hearts. And so this is going to be multi-step. We have one step and another step. We need to multiply those. So we're going to have step 1 and step 2 in order to receive our probability, or calculate our probability. So as we're looking at this, we're going to make an assumption that we are drawing a heart on the first draw. Okay, so when we do our first pull, we draw our first card, we have 52 cards total that we can draw out of. So consider, out of all of those cards, how many are hearts? And you'll have that number there. On your second one, you're not putting that card back into the deck, meaning you have 52 minus that one that you already pulled, so you have 51 cards available. And then we're also considering that we drew a heart in that first step, and so we are down one heart. So how many does that leave us? We're going to put that value here. Multiply those together, it's going to give you your answer. Move on to this next one. What's the probability that the first card is a 10 and the second card is either a 5 or a 6? So we're starting again with 52 cards. On the second step, we are not putting that card back in, so we only have 51 cards. And in this first step, we're dealing with tens. How many tens do we have out of the whole deck? We'll put that number there. And in the second draw, we're either a 5 or a 6. Well, this 10 has, if we drew a 10, that has no impact on our ability to draw a 5 or a 6. And so this number is not going to impact this number the way that it did on here. So we just consider how many 5s or 6s do we have in this deck. Out of those 51 that are left, we'll put that number, these are our 5s or 6s, and calculate that, get our answer. C completely changes things because now we are looking at this key phrase right here. We are going to replace that card. So we're going to draw a card, we're going to throw it right back in the deck. There's a chance we could draw that exact same card again. So we're starting out with 52. Again, this is multi-step. We're going to multiply each of these together. So ask yourself, if I start with 52, I put it right back in, how many do I have? Well, we've got 52 now, again. And we're going back and looking at A, so we're back with hearts. How many hearts do we have on the first one? And then if we're putting that, if we drew a heart and we put it right back in, does that change our chance of getting a heart the second time? Consider that, put your number right up there, calculate those, and you'll get your probability. So on this third one, or on the fourth one rather, I'm not going to lie, I had to Google this because it was challenging for me. But I'll show you the path for how I ended up where I ended up. So we have a game of blackjack, and we want to know what the probability is of getting blackjack with only 2 cards. Because of course we know that you can get blackjack with more than 2 cards, but we're just limiting this to 2 cards only, which means that we're going to have something with a face value of 10, and we're going to have an ace, which is an 11, has a face value of 11. So we need 10 points, and we need 11 points to equal the 21 that gets us blackjack. How many, I'm going to go ahead and set this up with my 52s because I know I'm dealing with 52 cards. How many opportunities do I have to get a card with a face value of 10? Well, it's common that we were just looking at these clues here, Jack, Queen, and King, going, okay, that's 3 opportunities, but are there any other opportunities? Well, yeah, we have a card in here that has 10 points to begin with. It's just the 10 card. So I'm going to put probability of that we need to consider we've got our 10, our jack, our queen, and our king. And then for our probability of 11 points, well, we're pretty limited on that. It's only going to be the ace. So if we have 4 cards and we have 4 suits for each of these, we're going to have 4 times 4, which gives us 16. And we have 4 aces in our deck, which gives us 4. Okay, so we've got that. This is multi-step. So we can go back and we can still do like what we've done before. So we've got our 52, our 52, and guys, I apologize. And actually, let me take this back. Get some cartoons playing in the background as my daughter's keeping herself entertained. If we have, so I just erased that because when we have our first opportunity here, we have 52 cards. We're not putting that card back in the deck, are we? No, we're not. So on the second one, we only have 51 cards available. And, you know, we're keeping this simpler than what it would really be because probably in a true situation, you would be playing at a card or a table with multiple people. And so there may not be 51 cards left in the deck. But we're, you know, keeping it as simple as possible. So 52 cards, and then on the second draw we'll have 51 cards available. We had 16 out of 52, and out of the remaining 51 cards, to draw an ace, it was either going to be, or it's going to be 4 out of those 51. So we calculate that, and we're going to end up with a value. So you guys may have done this and plugged that in, and it said wrong, wrong. And that's what I did the first time. It's like, ah! So this is when I had to Google it. And what I learned is that, you know, it's not a situation where you're only going to, this is not always the order that it could happen in. It could happen where you draw your 10 value first and then you draw your ace, or you draw your ace value first and then you draw your 10. So because of that, since there are 2 different ways it could happen, we're going to take that times 2. And I don't fully understand the logic behind that. I mean, I kind of do, but not enough to explain it further than that. But that's going to give you your ultimate number. So this is the number that you will want to plug into MyStatLab. So I hope that helps, guys, and have fun with it.